All right, let's try this again. So, class?
Yes.
Thank you. Okay, if you guys can pretend like you want to be here, so can I. I love it. Okay, so example 5. These ones right here are the difficult ones. That's why I saved it to have its own day. Okay, save these notes to have its own day. Example 5. 3 people are randomly selected and 1 person at a time is selected from 5 freshmen, 2 sophomore, 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. Okay, I said a whole bunch of words. Okay, I did say a whole bunch of words. First, how many students am I dealing with?
11.
Because we did this on Friday. Yeah, remember when you ditched? Yeah, okay, anyway. So, there is 11. Thank you very much. Yes, go ahead. Are they? And guess where I found them? Right there. You left them there, and they were there over the weekend too. So, yeah, okay. Wow, okay. So now that we're paying attention again, how many do we have? We have 11. 5 freshmen, 2 sophomore, 4 juniors. Now, the first person I'm going to select is going to be a what?
Which one is that? 11.7.
I know, right? Okay. How many freshmen do we have? 5. There's 5 freshmen. So, now, when I select this freshman, am I going to take this freshman out and put him back in?
No.
No. I'm not going to put the freshman back in. So that means that my total for my next time is going to be how many? 10. I'm reducing because I already took away one of them, right?
Yeah.
But I took away a freshman, so how many freshmen are left to choose from? 4. Very good. By subtracting 1. That's what it's called by being dependent. It's dependent on what I picked the first one, what I'm going to have the next one. My last one. So my third one is going to be a junior, but how many are total left to pick from?
9.
9. There's 9 because I keep subtracting 1 every time. So it's 9, but now I'm picking juniors. How many juniors? 4. There we go. Multiply that out for me if you could, please. Yes, please, and thank you.
8 over 8, 99.
Very good. 8 over 99. And what do we get as a decimal then?
0.08.
It's like 0.8 repeating, right? It's like that.
Yeah.
Okay. Now, if I was going to convert that into a percent, move the decimal over twice, right?
Yeah.
And I should get 8. Or if I'm also approximating it, that would be 8.1%. So all 3 ways are important that might be asked for on the homework. So you need to know how to do all of them. So, can we do it?
Yes, we can.
Thank you. Thank you. I got one of those at least. Now, this is the hardest one that we're going to have ever. Ever. Because no one's going to miss out on this, right? Everyone's paying 100%. So, conditional probability. The probability of event B, assuming event A has already occurred, is called the conditional probability of B given A. This probability is denoted like this. So, see this notation. This is important. So, if you see the notation in the homework, you need to know where it goes, what that means. Right there. Okay? Make sense? Okay, so that's conditional probability. Here's us actually using this. A letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome is a letter that precedes H. Now, you're going to write this down right now. Always start with the given. Always start with the
Given.
Escriba, por favor. Tú. Reyes, you good? Zone out a little bit? You need something to write with? Okay. Okay. I said, always start with the. Always start with the. starts with an A, letter A. Always start with given. Given. With given. So where are we starting at on this one? The given. Good. Okay. All right. Since we are starting with the given, that means that this is going to be the first thing I do. You guys know your alphabet? No. Quite possibly, right? Okay, it says, given that the outcome is a letter that precedes H. The precede, is that before or after? Before. The word precede means before. Precede is before. Okay, now let's count. Let's alphabet. I know my ABCs. A, B, C, D, E, F, G, H. Yeah, I'm not going any further. You know why?
Why?
Because I'm only looking for stuff that precedes H, so before H.
Oh, that's the.
Yeah. So all those right there. Did I do that on purpose?
Yeah.
Am I trying to like downplay this? No, it's not kind of childish on this. If you write it out, it's going to make it easier for you. So when you like get stuck on one of these because it's hard to fill it out, write out the alphabet and you can pick out the letters it's talking about. It's going to help you with this. So we're starting with this. So that means how many letters am I dealing with if it's only the letters before H?
7.
Let's see. 1, 2, 3, 4, 5, 6, 7. Okay?
Hey, I guess that.
There's 7 letters. So that means that this is my starting. I'm only looking at this group right here. So it's out of 7 from that group. Vowels. What are my vowels? A and E. Now for those people, let's say we got some foreigners in here. My vowels are A, E, I, O, and U.
Sometimes what?
Sometimes.
Hey, don't leave me like that. It's part of the song.
I know it is, but still. But yeah, for mathematical purposes, don't include the I.
Why?
See what I did there? All right. Now, I only have how many vowels here? 2. Very good. Do the math. Go ahead, Brian. We're waiting on you. This one's all you, Brian. 2 divided by 7, Brian. You. Okay, I'm sorry. Go ahead. Say it again. 285 like that? Okay. And that would give me approximately 28.5. Is that difficult?
No.
Now that you paid attention, we're all on the same path. It's the biggest part is actually getting it set up.
Yeah.
That's the biggest part right here. So let's do another one, but this next one here, it says mammogram screening on 100,000 U.S. women ages 40 to 49, assuming that these numbers are representative of all U.S. women ages 40 to 49. Find the probability that a woman in this age range has a positive mammogram given that she does not have breast cancer. Okay, what am I starting with? Brian, what do I start with? The given. In this case, my given is...
Oh. She does not.
Given she does not have breast cancer. So, find that category. That just so happened to be this second one right here, right? So that means the only thing I'm dealing with is stuff in this box right here. Those are the only ones I'm dealing with there. Okay? These other ones don't matter. Because I'm only using and only picking out of that group. What's my total there? 99,200, right? Okay. Ah. So there's my total there. Now out of this group it says, so I establish my given, what I'm working with, and which one am I looking for? I'm looking for,
Not.
no, right here. So right here, has a positive mammogram. So that's what I'm looking for. I'm looking for a positive mammogram in this group, what I've already established. So who has a positive mammogram? Right here at 6944. Does that make sense or is that no?
That makes sense.
Okay, because I always start with my given and then I go and find my piece. So 6944. Divide that out. 7 over 100, right? Which gives me what percent? 7%. So in reality, what this is actually saying is those women that don't have breast cancer also have a positive mammogram. So that means it's like a false positive. So it is possible to have a positive mammogram and not have cancer. So it's 7% chance. That make sense? Questions, concerns, complaints, conspiracy theories? No? Yes, you can get your headset now. I know that's what you're waiting on.
I was not here on Friday, so you have to video me.
Yes, I do. All right. So make sure you guys all like, share, and subscribe.